Coming up on This Week in Radio Tech, our 5G spectrum C-band satellite dishes, that could be in trouble. The big 5G carriers want a piece of it, and it could spell interference for us as broadcasters. Radio, TV, cable head ends, and even more. We're talking about with Mark Johnson and Chris Tobin coming up on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, saving, and support. Online at bgs.cc. By the new Ruby console from Lavo. See Lavo in your future at lavo.com/TWiRT. And by the Telus Alliance, shaping the future of audio, inspiring you to create the most exciting and engaging audio experiences imaginable. Visit telusalliance.com/opt-in.
Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. I'm so delighted that you're here, the show where we talk about radio technology and the stuff that everything, well, as we say, between the microphone, there's the microphone, between the microphone and the light bulb at the top of the tower and everything in between. And today we're going to be talking about an antenna, but not the usual antenna that we talk about. So we got a guest coming up. I'll tell you about him in just a second. Chris Tobin is not joining us at the very beginning of the show. He may be able to join us during the show. As I said, I'm Kirk Harnack. I work for the folks at the Telus Alliance. That's my full-time job. So if you hear any bias in that direction, well, that's probably why. And I'm a broadcast engineer. I sort of, kind of, as best I can, take care of the engineering needs of 14 small market, very tiny market radio stations, and try to have a good time with that and try out some of the latest technologies at those stations whenever we can to make my job easier and to make the job of the people who work there easier and maybe save some money too. Well, if you read the tease for today's show, you read about the fact that there is a critical a thing of critical importance that's come upon us, having to do with utilization of a radio frequency band that almost every radio station depends on. Or I would say at least half, if not more than half of all the stations depend upon this radio frequency band, and it is in some jeopardy. And there's a perfectly good, worthwhile technical debate about it. There's also a bit of a political debate about it, and there's some action items that we as broadcasters can do to perhaps save ourselves a whole lot of trouble as we move forward. It could even actually it could even save some local radio stations from demise. It's that serious. So I want to bring in our guest, and it is Mark Johnson. Mark is the founder and operations director at LiNKUP Communications. Mark, welcome into This Week in Radio Tech.
Hey, Kirk. Thank you very much. Glad to be with you. It's
good to see you. And did you and I meet when with an outfit called KU?
Yeah, that was the previous iteration of LiNKUP Communications. We had some changes in the structure of the company, and KU became LiNKUP. We've kind of expanded into doing more of the ground systems as well as the space segment. So we've been pretty busy this last 2 years.
Well, we've got a real serious topic to talk about, but I hope during the course of the show we also get to talk about some practical advice and maybe even a war story or two about you and installing satellite dishes, uplinks and downlinks, and how just what you do and what this technology does for broadcasting. I think we all have kind of a good idea, but it's nice to be reminded about this amazing satellite technology and how, in a way, how robust it is, but also how fragile it can be when politicians and cronyism gets involved. So we're going to talk about that too. So, Mark, we'll roll right into the show in just a minute. Our first sponsor, I want to tell you, is the folks at the Telus Alliance, my friends at Telus, and we're talking about the Telus VX. Now, we've talked about it before, but I'm telling you, I'm on the mailing list when companies, when radio stations, now television stations, when they inquire with one of our dealers or with Telus Alliance directly about what can the Telus VX phone system do for me, I'm seeing all these requests come in as part of my job. And I am amazed at how many broadcasters are now really seriously looking into voice over IP, not just for their business operations, and many people have been on that for a while, but moving to voice over IP for their on-air operations. For radio, of course, this means putting callers on the air talk shows and news gathering, that kind of thing, getting actualities from interviews, plenty of that going on, especially in the bigger cities, but in any station with a news department, or you need an actuality or a sound bite. But we also find that television stations are really picking up on the Telus VX. Why? Well, television stations typically in their local news department, and by the way, that's one of the few ways that TV stations can make money, is by having a local news department. And so many TV stations have expanded the number of hours of locally produced newscasts. And a lot of you may know that I do weather on a fill-in basis for the NBC affiliate here in Nashville. And man, they have, like all the other stations, or most of them, they've really expanded their news offerings. Weekdays starting at 4 a.m. and going until 7 a.m. with cut-ins then between 7 and 9. And then in the evening, 4 p.m. until 7 p.m. with just a half hour cut out for the network news. And then a half hour at night. And some TV stations are doing even more than that. Well, this implies that there are news crews out there, because nothing, says, hey, we're on it, like putting a reporter out in the field. And that's where am I going with this? That's where the Telus VX comes in, because these reporters in the field, these photogs, news crews, news trucks, and as I said, the reporters, they need good communications in two ways: with the producer, the director, back at the TV station, also the assignment desk. And that's where Telus VX comes in, because I tell you, a lot of TV stations are paying a ton of money for POTS lines or for ISDN lines that the reporters, the people outside, call in and connect to the intercom system. Well, the Telus VX can handle that for you, and can do it with VoIP lines, which, my goodness, look, you can pay as much for VoIP lines as regular POTS lines cost, but you can also get VoIP lines for next to nothing, or anywhere in between, depending on how much management of the VoIP you want. There's a lot of choices out there. It used to be we had one choice. We'd call the incumbent phone company. In a lot of places that would be AT&T, or it used to be Bell South or Bell Atlantic or Mountain Bell or whatever. And then for some years it was just AT&T or GTE or whatever your carrier was, CenturyLink now or Frontier. But with VoIP, you've got a ton of options to have it either hosted outside, to bring trunks directly into you, to have where you can have equipment there. And that's where the VX comes in. So the VX kind of forces you to go to this new technology. But that's a good thing, because this new technology can save you on the order of 90%, maybe 85%, maybe 80%, maybe just 50%, depending on what kind of VoIP service you get. But I have talked to TV and radio stations all over the country, and a couple out of the U.S., where they say their return on investment for putting in a Telus VX multi-studio talk show system, their return on investment anywhere from 16 months to 3 years. So that means after 16 months to 3 years, it's paid for, and they're saving this money every single month. I was at a TV station about a year ago where they were spending close to $3,000 a month on POTS phone lines. They got rid of all those and went with a VoIP system, cost them a few $100s a month. And they bring those VoIP lines into the VX. The VX is programmed specially to route those calls to their intercom system, or to on the air if they like. And they have got great communications with their outside people, photogs, reporters, and truck operators. And it works so well. If you think, in fact, hey, I just answered an inquiry from a TV station right here in Nashville, and I'm excited for them to be putting one in right here in Nashville. The Telus VX, whether you're doing radio, talk shows, that kind of thing, news gathering, or whether you're doing television, the Telus VX can really force you to save money by moving you into the world of voice over IP. It's cool, it's fun, and it really works. We got some real experts at Telus. Go to telusalliance.com to find out more. We appreciate Telus for sponsoring This Week in Radio Tech. All right, we're with Mark Johnson talking about satellite communications. Mark, you told me, you kind of put the fear of God into me on this problem, that the broadcast, and not just radio, but television and cable is facing too. Lay this problem out for me, if you would.
Okay. So as we all know in radio, the content that gets delivered to us from state networks, regional networks, sports networks, IMG, farm networks, all of that content comes to our radio station via C-band, and it's the 12 to 15 foot dish that sits out at your studio or at the transmitter site, and in fact, many stations who are taking ESPN or a talk format, 95 to 99% of what they broadcast on a daily basis comes through that C-band satellite connection. And why did we go to C-band? Well, we went to C-band because it is incredibly reliable. It typically, when you do a link budget for a C-band system, you're talking about 99.99% reliable. I mean, I've seen it operate in hurricanes, and there's no other technology, either satellite or terrestrial, that competes with that kind of reliability. And when you're a broadcaster, it doesn't take but a moment or two of being off the air for somebody to change channels. And especially in a news situation or a weather situation, which you're incredibly familiar with, if you've got a weather emergency, which we have, pretty regularly here on the Gulf Coast, being on the air and being reliable in inclement weather is critical to broadcasters. But it's not just us in radio.
Hey, I want to ask you.
Go ahead.
I want to ask you a quick technical question about C-band, because I get this question once in a while from non-radio people. Why don't you guys just use those little satellite dishes like Dish Network uses? Why do you have to have that huge satellite dish? And I'm sure part of the answer is, because for consumers, they're going to deploy literally hundreds of thousands of satellite dishes. They need to be cheap, inexpensive, and work most of the time. And so the band that's used, regulates the size of the antenna that's needed, and there you go with the little antennas. But broadcasters don't need it to work most of the time. We need it to work all of the time. And
that's right.
Broadcasters might be expected to have to put out and pay for a bigger antenna, anywhere from $1,000 to upwards of $15,000 or $20,000 for a big honking antenna. So if you could tell me, technically, why is C-band right for the kind of distribution that we do as broadcasters, and then maybe we'll get into why is it right for other people that would like to encroach on it.
Yeah, C-band and Ku-band are the major satellite frequency bands that we as broadcasters use. Ku-band is typically the smaller dish. It is good for remote vehicles. It's good for distribution in Western climates where rain is limited and precipitation is usually not heavy. But C-band, because of the wavelength of C-band and the wavelength of Ku-band, C-band is more reliable in heavy precipitation. Now, and typically what rain, precipitation, stuff in the sky between the dish and the satellite, everything that comes in between it becomes attenuation. And because C-band is not the same wavelength as a drop of water, it takes a lot of water to attenuate C-band. Ku-band, however, is the same wavelength as a drop of water. So a tall thunderstorm can carry 15, 20 dB of attenuation on a Ku-band signal. So in Panama City, where I live, you can put in a Ku-band dish, but there's a good chance that 60, 70 days a year, you're going to have a big thunderstorm come through and you're going to be out for some period of time. That doesn't really work for a 24/7 broadcast application. It doesn't work for a sports cast. You're right in the middle of a college football game, rain comes through and you miss the scoring play and the 4 ads that ran after the play. pretty soon you're not going to be in business. So in the late 70s, Mutual and NPR kind of took the lead with starting to distribute by satellite, and they chose C-band. And they started cutting. Yep, and they started cutting the AT&T lines that did distribution. And then in 1983, they were followed by, Westwood, what became Westwood, but CBS and ABC and Mutual, and that distribution became C-band 100% in 1983, and we've been there. It's been reliable. We serve our communities, and you look at these small market stations, and they, maybe can afford a local morning show, maybe not. And then the rest of the day, they're bringing content into their market that's interesting to that market, but they're bringing it in by satellite. The satellite has no recurring cost to the radio station. And every other solution either has recurring cost to the radio station or has reliability questions. And that's what different networks, commercial networks, as well as NPR, as well as providers like us, have been trying to share with the FCC about. This is a critical piece of broadcast infrastructure. And it's not just critical to us as radio broadcasters, as powerful as what you and I have just kind of laid out. Every TV station gets their network programming and their syndicated programming off of a C-band downlink. Mm-hmm. As Comcast put in their ex parte to the FCC about this, 86% of all programming that goes over their cable head-ends comes in by C-band. So it's broadcasting and cable, and it is a powerful tool that we use, and it's being coveted by 5G and broadband. Extremely, they're putting an extreme full court press as we start to get into college sports seasons.
So that begs the question, and you've done a great job of explaining why C-band is great for broadcasters, why that frequency band works well for the way that we use it. And oh my goodness, we use it. I mean, I've got several radio stations with satellite dishes. We even record. We have a station in American Samoa, and there's no satellite footprint coverage there from what's the name of the bird now that's way west that most of the networks are on? I forget the name of that bird.
Well, it used to be, they used to be on AMC 8. They've moved 18 into that slot.
That's right. It's no longer way west. It's partly up. Yeah, we had to move our dishes. That's right. But there's no coverage there's no footprint in American Samoa. I've tried it, by the way, with an 11-meter dish, and there was 1 dB of carrier to noise ratio on an 11-meter dish. So, directional antennas on satellites really do work. So what my station does, and I realize we're just small potatoes here, but we record several different newscasts on the mainland here, and we FTP them to American Samoa. And we have network affiliation agreements, but we have to take care of getting the newscasts out there ourselves. And so we're just a few minutes late. We're, almost just in time, within 15 minutes, we're playing the network news. But again, radio kind of important, yes, but you bring up television, it's all there, and all these cable head ends. Now, what's the threat? Why is this band being threatened?
Well, several years ago, a couple of groups got together. One of those groups being what they call 3GPP, which is it's an assortment of telecommunications groups, and the International Telecommunications Union. And they got together and they started planning what comes after LTE, 4G. What comes next? And they're imagining everything that you possibly own should be connected to the internet. Your washing machine, your car, your electric circuit, everything needs to be connected to the internet. And so they need or want or are requesting tremendous amounts of bandwidth. And so what they did was they went after several of the high bands, specifically the 24, let me see if I can pull this up real quick, 24, 27, there's several in here. I'm trying to find it. But there are about 5 or 6 bands in the high bands that they want. And then they want the mid band, and they want the 3.7 to 4.2. And their rationale is really the same one as ours, which is it is resistant to rain. It's resistant to precipitation. It's a more robust signal. And so with the higher frequencies, as you get into this, they're going to need to put systems every 2,000 feet. So they're going to want them every 2,000 feet. And they'll go into a city and they'll put them on utility poles, they'll put them on buildings. They're going to have all these microcells connected, and they need it to be resistant. Well, the reason we picked CBand 4 decades ago was because it was reliable and resistant to precipitation. So,
hey, I just found an interesting statement here. This is an article, and I'm sure you know this, but this says it pretty well. Is C-band the global 5G frequency? C-band is becoming one of the few spectral bands on which the global telco industry is converging due to the abundance of available spectrum. Yeah, okay. And its relatively favorable propagation characteristics, especially when compared with millimeter wave. C-band networks can take advantage of cutting-edge cellular technologies like massive MIMO antennas, carrier aggregation, and can introduce large amounts of spectrum per operator. So, yeah, it's like a big, So, sounds like broadcasters are using something. It's worked well for us, but it's real attractive to people who are deploying, massive amounts of 5G connectivity.
Right, and you're talking about the some of the most profitable companies in the world. You're talking about Microsoft. You're talking about Google. You're talking about Verizon. These are third of $1 trillion, half a $1 trillion companies, and they've got a lot of worldwide political power, and so they want this spectrum. Ericsson and Qualcomm have already started making handsets for 5G, and even though the NPRM's comment period is just starting, they're already go into production with stuff. That's how much money is involved in this and how confident they are.
Wow. Okay. So the spectrum that we've been used to using for years and years, because it works well for us, is at risk. And so what we've been hearing from various broadcast proponents like the NAB or our state broadcast associations is that the way to stave off this encroachment or this band sharing that they propose to do, we'll use these frequencies where it won't bother anybody, but in places where it would interfere, then we won't use it in that geolocation. And so the idea is that every broadcaster, everybody that has a receiving C-band dish, TV stations, cable operators, and radio stations usually being the poorest among us, need to register our satellite dish so that the FCC has it in a database. Yes, there's somebody at this location with this look angle using this bit of spectrum right here. Don't interfere with it. Am I saying that right? That the only way
Yes.
to make this happen is you got to register your dish, right?
That's right. And in the NPRM, it takes about 3 or 4 pages to get past all of the glittering generalities about 5G. But when you get to it, one of the first things that the FCC says is that they understand that they don't have current up-to-date data, and the reason that they know that is because SES and Intelsat not only kept going back, but they invited other people to come in. Jim Leifer and Chris Emile from the SBE went in. Karen and I went in, and we just reiterated that your information is inaccurate. And we did things to show them that their information was missing, it was lacking, and that they needed to understand how many downlink locations, not just dishes, but locations, there are in the United States. Typically, SES and Intelsat tried to explain, there's at least 30,000 sites. And, it doesn't take a whole lot of research on the internet to go, all right, how many cable companies and how many cable head ends are there? How many broadcast television stations are there? How many broadcast radio stations are there? Regardless of what the format is, the facility typically has a downlink, whether it's a country station that maybe plays a format from Westwood, or it's a ESPN affiliate, or is it a premier affiliate taking talk? They're going to be taking stuff off of the satellite, and even if they've got local programming, they're maybe taking sports from IMG. And then you take the public radio stations. There's 1,200 right there, and you take Christian radio. Well, they get either their format, their full-time O&O distribution, or their content in the half hour and hour versions, and that comes in on CBand. So they're all putting this together and saying, look, there's 25 to 30,000. And so actually what I did was I just took my county here, Bay County, where we have approximately 12 locations between radio, television, and cable, and said, look, there's 120,000 people here. There's 12 locations, not dishes, because TV stations have multiple dishes. Cable head ends have, a dozen dishes, but there's just locations. Extrapolate that across the country of 330 million people, turns out to be 27,500 sites. So all of this reiteration of there's more than led them to open this window and then extend the window. So they've extended the window to October 17th for us to register. And they say they want to know who is out there. And if you're not registered, you'll get no consideration or protection. And they're very specific about that. You've got to be registered to get that that consideration is kind of the word they use. But we expect that, as Intelsat and SES look at filters and things like that, that, if somebody wants to come into your area with 5G, that if you're in the FCC database, then you will get consideration.
So I want to summarize something that we talked about earlier, and then we're going to take a quick quick break. And that is that. So there's some powerful forces that want the spectrum. These big phone carriers, $1 trillion or parts of $1 trillion company, and it seems that the FCC really wants to give the spectrum to them. The FCC is really focused on mobile technology, and so they want to. They're interested in finding ways to share this the spectrum, and even if it's to the detriment of broadcasters that have been around for over 100 years, and still serve the public good at zero cost to the public. Then you have companies like SES and Intelsat that they're the licensees of the transmitters in the sky, right? They're the satellite operators. They don't want they don't want to have a crappy product to sell their customers being the networks, whether it be a regional network or a nationwide network. They want to have a quality product to sell the network. So the satellite companies are interested in, no, we don't want to share this space. This is our space. It was licensed to us years ago. And of course, broadcasters don't want this encroachment either. And then the network operators like Westwood One or IMG networks, they don't want this encroachment either. They want their customers, us radio and TV stations, to have easy, clear signals. And so you said registering was the sure way, or the surest way, to protect your ability to receive. And when we come back from the break, I want to understand from you, and we'll look at some pictures too, as to why it's possible, it's even likely to interfere with your reception of these relatively weak TV and radio signals from the sky, even if there's nobody transmitting right on your frequency. And I think plenty of engineers have experienced this with AT&T long lines from back 20 years ago or more, and from ship radar at ports of call. People had interference with this, but we'll get to that. And I'm interested to see, also what you can tell us about stations, the cost of registering, but they may be able to get reimbursed for that. And that's a big deal. I've got 14 radio stations, not that many dishes, but I've got 14 radio stations in 5-6 locations. And yeah, I want to protect those, but I don't have $400+ per location to register this. So that's coming up. That's the tease. We'll do it. Hey, a part of our show is brought to you by our friends at Vox Pro. If you are an on-air personality, you know how great Vox Pro is and what it is. If you don't know, you're about to see right now. Let's check it out.
Scott Feibush here at Wheatstone at NAB, and one of the attractions of the booth is one of the masters of the Vox Pro cadence here. We got the Vox Pro 7.
Yeah, new Vox Pro 7.
What is new? What's exciting?
So many new features. We got a built-in, like a mini processor. You can adjust EQs, de-essing, almost like a mini production studio. You want to jack up the levels if you got a low caller. Also, we got the gap buster, where instead of sitting here on the Vox Pro, if you're an advanced a Vox Pro person, instead of sitting there and editing out all the silence and stuff, basically hit 2 buttons and all of that is done for you. It's all about the shortcuts this year. Also, they built FX macros, which is basically a shortcut button that you establish at the top of your file. And instead of sitting there for 2.5 minutes during a song editing, all the ins and outs of the phone call, you can hit 2 or 3 buttons and in real time, doing it in about 20% of the time.
So this is what we're going to see you demonstrating here.
Yeah, for sure. And last year we went into the hotkey portion, and we can get a little bit more advanced and stuff like that. But there's just so much more stuff that is coming out with the Vox Pro 7 here at NAB 2017.
I'm going to stand back and watch you do your magic.
All right.
Thanks a lot to Vox Pro and Wheatstone for sponsoring This Week in Radio Tech. Really appreciate it. You should go and check it out. You can get a Vox Pro from our sponsor, Broadcasters General Store. You do that by going to the website, bgs.cc, bgs.cc, or call them at 352-622-7700, Broadcasters General Store. They represent and will be glad to ship you, for money, of course, a Vox Pro system. Really cool. Hey, you're watching or listening to This Week in Radio Tech. It's episode number 409. We've been doing this for a while, and our guest is Mark Johnson with LiNKUP Communications. But we're not talking about LiNKUP specifically. We're talking about the possible encroachment on a band of RF energy that we broadcasters really depend on. Radio, TV, and also cable head ends depend upon. It's the C-band that we've been so used to for decades. Mark earlier mentioned it was NPR and Mutual that's first started using C-band back in the late 70s. And I worked at an NPR station back then. And back then we thought it was so fragile that this NPR station actually dug a trench to put the dish down in the trench, in the ground, And guess what? They got one look angle. That was it. And it went, and so they could look at the satellite because there was a nearby AT&T long lines tower, and they figured they had to stay away from that interference. Hey, and Chris Tobin has been able to jump in here with us. Chris, are you with us, buddy?
I'm here.
Oh, your audio is really low. I'm not sure where the lowness. Yeah, it's still a little bit. Oh, I think. Yeah.
Oh, what's the matter?
I don't know.
That's good.
Are you on that mic?
I am on this microphone. Yes.
Oh, that's much better right there. That's much better.
All right.
Almost sounds like a ducking issue. Hey, well, anyway, welcome in. Are you in Newark?
Yes, I am. I'm in one of the news production booths. So,
awesome.
Yeah. Oh, I got around for the split shot there. Sorry.
Good deal. So, Chris, obviously we've been talking about C-band, and you've joined us just in time because we've reviewed something you already know, and that is the importance of C-band, why it's important to broadcasters, why it's the ideal frequency to distribute television and radio programming on a nationwide or a regional basis, why it's not appropriate for, let's say, Dish Network or DirecTV to use, but it's really optimized. It's the right band to use for, reasonably more expensive than home, but not ridiculously expensive receiving equipment. A dish that's 3.7 or 4 meters across, to get the right, to aim at the satellite for the right spacing and that kind of thing. And that it's not impervious to, but it's much less susceptible to rain fade. Whereas, a consumer satellite dish could stand to be out for a few minutes. Broadcasters don't want that at all. So we've examined why C-band is terrific. But also, that what makes it terrific for us as broadcasters also makes it highly desirable for these big 5G rollouts that are coming down the pike. And unfortunately, lots of other countries agree. Oh, C-band is great for 5G. And in fact, we've allowed our carriers to use all the 5G they want. And so the problem here in the U.S. is that we depend on it very highly. Now, the idea there that the FCC, of course, and for years we've heard about, using white spaces, wireless mics might be able to share frequency with TV stations and all this kind of stuff. And yeah, technology maybe ought to get us there, but you can interfere with a C-band receive-only dish without a whole lot of power from miles away. And we were just getting to that point with Mark Johnson, our guest from LiNKUP Communications. So, Mark, if you could to take Chris and I through this idea now of how easily this little tiny signal from space can be obliterated by a not so nearby transmitter that's supposed to share the spectrum.
Well, that's right. Well, you think about, you've got a dish and basically an amplifier at the end of the dish, and you're trying to corral a very faint signal from 22,300 miles away. And you're trying to bring that signal in and then amplify it and then feed it to your satellite receiver and then take quality, reliable programming off of that dish. Well, if you put a much larger signal a mile or two away, it's the noise just completely cancels out anything that you want to try to grab. And we've seen this ourselves when we've been near a WiMAX facility with a downlink.
So we have a graphic. We have a couple graphics you provided. Let me see if I don't know if Suncast, our producer, is able to get those up or not. But Suncast, I sent you a couple of graphics that look like little spectrum displays. And if you can pop those, oh yeah, here we go. Oh, what we looking at here, Mark?
Well, when our guys go out to survey a site that we're going to do a downlink for, this is a radio station, and we take the old low noise amplifier, which looks at the exact spectrum, and we swing it around and look, and the carrier to the left is a WiMAX facility in that area. And what it does is it's outside the band, whereas 5G wants to be in band with us. This is outside the band. And and this can raise the noise floor 10, 15, 20 dB because it's so much more powerful than what the LNB is expecting to to find. It's so much more powerful that it reproduces energy across the frequency that it sees, and so that raises the noise floor inside the LNB. And when you've got a signal that's 30, 40, 50 dB above the noise floor, raising it up, then that 10, 15, 19 dB W carrier that you're expecting to find on a satellite 22,000 miles away suddenly is just completely overshadowed, and you can't pull it out.
So it sounds like, technically speaking, and Chris, you kind of chime in too. If we were dealing with, let's say, a use case where we weren't dealing with satellites, but we were dealing with, let's say, a radio station was using some C-band to transmit a studio transmitter link, so, something local, something comparable in power, use, and coverage area to what the 5G companies are proposing. Well, we could deal with this kind of disparity in signal levels. But the use cases here are completely and wildly different. In one use case, the broadcasters, we're picking up this T90 signal from way away, and that's why we have a 12 or 13-foot dish antenna to collect all we can from that satellite and pinpoint it down to a little antenna on the LNA or LNB, more likely. Whereas 5G technology, they're trying to blast out some signals so that I can pick it up with this, no matter how I have it oriented or where it is, even if it's, under the seat in my car. And, and so quite different use cases. And therein comes the rub. We as broadcasters need this to work in a very low signal level, and we need clean spectrum to pick that up. The 5G case is totally different. They just want to blast it around in a local area. Chris, you've joined us here, and I know in New York City, you've got a whole lot of C-band receive sites. I'm guessing, and Mark will comment on this in a minute, I'm guessing that with all the C-band receive sites in New York, if they all got registered, these 5G companies really don't have a prayer of putting their 5G transmitters in the C-band in New York City, do they?
Sure. I can give you 8 billion reasons why they have the ability to do that.
That's right.
Well, what could you be talking about, Chris?
Yeah. Let's see. What Mark was talking about is raising the noise floor, and for terms of FM engineers and AM engineers, that would be known as blanketing interference. And that's what you typically get when you drive past an FM transmitter, and you're listening to your favorite station that's not on channel. The transmitter site's at 102.3, say, and you're driving by listening at 103.5, and all of a sudden your radio goes blank. Goes into blending, or it does some crazy things for a certain distance, which is calculated mathematically as to what it will be for the blanketing interference, class A, class B, the whole bit. And that's what you're getting pretty much. At C-band, it's the same thing. So when I was working at two of the networks years ago and managing the uplink station, it was interesting talking with Jeff Watts, formerly of GE Americom at the Vernon Valley facility in New Jersey. That was the uplink, or it's the Earth station, or flying, I should say, flying the spacecraft out of for AMC 8 now. And he always used to tell me, he goes, it's amazing. The reason we're out here in the middle of nowhere is back in the day, these huge, 11-meter dishes, and they're huge out there. There was too much noise near the city. We had to come all the way out here to get below the noise floor in order to operate, which is still true in many cases for some uplink facilities. And if that's not the case, when I was managing an Earth station in the city on a rooftop of a broadcast building, we had to sort of put up walls around it to minimize the TI, the terrestrial interference that we'd get from the sides and around and everything else. So I can just imagine, and Mark, I'm sure, has already experienced this in parts of his world. I'm thinking, some type of 3 gig transmitter within, half a mile of my studio downlink is probably going to give me grief, because there's a good chance my dish may not have the side lobe rejection you'd like. I never had a need for it, but now I do. All these small details. And how about those stations that have dishes that are very large because they may be at the edge of the signal? If you're on the East Coast and you're looking at AMC 8, you're about 9 degrees above the horizon. So you're working with a lot of crazy stuff and digging out the ground in front of you if you're up farther north from where I am to just get to that signal. I pretty sure we're going to see and hear a lot of craziness with this proposal. And yes, the rest of the world, was the WARC world area, the worldwide radio conference, WRC, they've already given away most of the land, so to speak.
And that's why it's important for as many radio stations as possible and TV stations and cable head-ends to get registered. First and foremost, get registered. The second piece of this is to comment on the notice for proposed rulemaking. I believe the comment period is open now. We've got 60 days to comment. And, the first 3 or 4 pages is, 5G, broadband, fluff of the NPRM. But later on, they say, hey, they want to know what we think. They want to know how we use it. We should accommodate them. We should fully explain how we use it, and let them know why we're here and how important what broadcasters do.
Well, if you just Google if you just Google NPRM and that's Notice of Proposed Rulemaking. I know that Mark has used that phrase a few times. NPRM is Notice of Proposed Rulemaking, and that's what the FCC does when they're proposing to make a change. They put that out for comment. If you Google NPRM, C-band, and 5G, you'll find plenty of articles. Some favoring or written by the wireless industry, and some by the broadcast industry. Taking sides as to what needs to be done, and the fact that it's out here. In a few minutes, Mark is going to have some specific suggestions about how to register your dish, and for those of us like little guys like me who, I don't have enough money to pay for the registration fee, which is over $400 to the FCC for each of these, that there may be a program to get reimbursed for that cost. Because there are some people that have a little bit deeper pockets that are interested in broadcasters like us making sure the FCC knows about all of our receive sites, so we can say, no, we're protected here. You cannot, don't interfere with us because here we are, and now we're in your database. And Mark, I want to wait a few more minutes before we get that, give people a chance to get their pencil handy, and also give Suncast a chance to get a couple of those links ready to show on the show. Mark, one thing that you and I talked about is that, there's all these receive sites, and the FCC's procedure is every receive site needs to register. Well, that seems like a whole lot of busy work to me when people like Westwood One, your friend and mine, Eric Weiler, in charge of satellite operations there at Westwood One. I mean, Westwood One knows where all the satellite receivers are, basically. And they may not know they could calculate the look angle. I mean, and they know where all their receivers are. They're even in control of all their receivers. Why couldn't it be that Westwood One and NBC and the other big networks, why couldn't they tell the FCC, here's where all our receive sites are? And why couldn't people like SES or Intelsat reiterate, hey, we've got a licensed coverage area that needs to be protected? Why is there this jockeying to encroach on these things? Why do we have to do what we have to do just to protect what should be ours?
Oh, it's guaranteed.
Great minds think alike. Eric said the exact same thing in a meeting recently, and asked the very same question, and the legal minds kind of went to it. He's like, look, I know where every one of my receivers are. I know what station it's at. I know what IP address it is. I know what programming they can receive. And if I don't want them to receive it, I can stop it. Same is true of Skyview and Premiere and ESPN. They can all do this. And there was some debate amongst attorneys as to what the FCC's language about ownership and control of the downlink meant, because it's supposed to be somebody who's either got ownership or has control of the downlink. And so there's some discussion as to what control means. So instead of waiting for that to get figured out, I think everybody just went with the idea, let's give the stations every resource that we can think of. Let's support them. Let's give them the information, and let's ask them again, and let's ask them another time to fill out their registration. And it's a much more, the International Bureau forms are much more complicated than the Media Bureau's forms. So it takes a little going through. Once you've been through it once, you're good. But that first time through, there's stuff you need to ask somebody, hey, what do I put here? What do I put there? And, one of the things is SES and Intelsat have both put together on their websites information that will provide assistance. They've also got email addresses and phone numbers so people can call and ask questions. We've got links to it on our website as well. And
if our producer Suncast could click on show that SES link. There we go, right there. And so this is, let's see, this is the graphic you sent me. There's also a, this is what SES is running an ad in industry magazines to right here. You can call that number there, the phone helpline, and FCC registration at ses.com. And plus there's another link that you can go to. We'll put that in the show notes, and maybe Suncast can show that link as well that I sent, that takes you to a web page with SES. And Intelsat has something similar. I'm sorry, Chris Tobin, you were just about to chime in there about this issue of registration versus en masse registration by the
that's
interested parties.
434 reasons why they have to do this registration this way. I mean, think about it.
Of course.
Common sense dictates it's a receive site, first of all. So, and we're, regardless of what does ownership have to do with anything in that respect? If you contact the network and say, excuse me, Mr. Network, how many program affiliates do you have for CBand? Oh, we have 4,500. Oh, okay. There's a first start. And can you verify that? Because if they don't have ownership or control, they wouldn't be getting a controlled access receiver to play out the programming material.
Yeah.
Say, small details like that. I mean, really, it's a game. It really is coming down to a game. Let's be honest. Who has the most money gets the game to win in their favor. Because just like Kirk, you pointed out, and Mark, and even Eric Weiler, says the same thing. And I'm sure there's 6 dozen other people and folks at SES and Intelsat. It's like, hello, wait a minute. It's a program service. It's there. It's licensed. You should have this information. We can get it out. What do you mean? Who owns control of what? Since when has that suddenly become the splitting hairs moment? Oh, that's right. It is a splitting hairs moment because just as Kirk pointed out, he can't afford the license fee. I'm sorry, the fee to properly register the site. So what happens? Let's play the game. 10 people are asked to license their site. It's going to cost you $450. 2 of the 10 can do it. 20% now is registered. Guess what? I look at the big picture. Well, look, only 20% of the people are using the service. You know what? We're going to give it to this other guy. That's what it's coming down to. Because in New York City alone, there's got to be at least 3 dozen C-band downlinks on top of rooftops. I can go on top of the building.
Yeah, they're everywhere.
And look across the horizon. Go, oh, there's C-band, 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 and then there's KU, but C-band. No, so don't let's not play games here, guys. This is the reality. Is 8 billion reasons why you're not going to get what you want unless you really push it. And unfortunately, we have to really work hard. The notice proposed rulemaking is the first step, and just keep pushing and register your sites. That's the best you can do at the start, and just keep going after it. And then contact your NAB delegate if you're an NAB member station, and say, hey, get on the case. You're a lobbying group. Get on the case. Let's go.
That webpage that we were just showing, that is the help page from SES. Of course, they have a vested interest because they're the satellite operator. And we'll put a link to that in the show notes. You can go to that page. You can ask them for help in filling it out. They have links to the form, and they can help you get the form filled out. Now, I didn't read it directly on there, Mark, and I know I keep harping back on this $400 and some registration fee. Maybe it's $435 or so. But you said that SES may have a program to reimburse you under certain circumstances.
Yeah, the SES started a program. I believe it's after anybody after July 28th, I believe is the date. They were looking to get people, and they've put aside some funds, and they will help reimburse people who have a hardship. And this is the same conversation that we had at the FCC where we described a small radio station in Bruton, Alabama, where a woman owns the station and she's got programming coming in from 4 different networks, and it provides full-time programming for that station, and that's the communications for that community. And whether it's her country format or whether it's University of Alabama football, it's coming in by a C-band. But her question was, well, what do I get for $435? And that's what we proposed. And we'd hoped that the FCC would make some movement on that. But once it became apparent that they weren't, SES, took responsibility, took some ownership there, and they have a program to help you out. And in the case of radio stations, it's completely in their neighborhood to want to do that, because the major radio networks are on SES SES 11, which is their bird. So if you fill it out, reach out to them through the website, reach out to them through the email or the phone number, and they'll give you details on how to do that. Both Intelsat and SES have examples of what your registration should look like when you complete it, and you can go by step, looking at what they've put together. And feel free to email or call either one of them, and they're there to assist you in this process.
Good deal. All right. We got to take a break here real quickly in just a minute. But Mark, I wanted to ask you, you mentioned that, of course, every radio station should register their C-band dishes as a receive location. Obviously, so should TV stations, and so should cable head ends. This show is about radio. You also mentioned about talking to your political representative, and you mentioned, Mark, the Energy and Commerce Committee. Of course, there's the FCC, but they don't represent us directly. They're not elected by us, but your representative who may be on the Energy and Commerce Committee may be elected by you. Well, tell me about that,
yes.
Mark.
The Energy and Commerce Committee has oversight of the FCC. And when we went in to speak to our congressman, who's not on that, I believe your congressman might be the chair of that committee. But when we went in, they said, you've got to talk to radio stations that are in the communities of people who sit on the Energy and Commerce Committee, regardless of their party. Because what they don't like is bad news from home, and they really don't like bad news from their local radio and TV stations back home. And so they will put together a letter, saying to the FCC, have you considered this? Have you really considered how this is going to impact the people in my district? And so, in addition to registering, commenting, and then letting the people in Congress know that, yeah, this is important to Google, but it's more important to us.
Gotcha. Yeah. Chris, by the way, I just looked it up. You can just Google the House Energy and Commerce Committee and see who the members are. It does turn out, Mark, you're right. Marsha Blackburn, who is not quite my congressional representative. I'm a few feet outside of her district. I've been to her office. She's a good lady. She's running for Senate from Tennessee as well. Anyway, but yeah, she's on the Energy and Commerce Committee. Chris, I'm sorry. Did you have something to say?
I was just going to say, if we make references to presidents, so to speak, of things that happened in the past with technologies and various bands that go in. How about the LTE situation with FM stations around the country? FM stations that are getting into LTE sites because of the blanketing interference, the power, because most LTE systems, or we'll say mobile cellular, whatever you want to call it, operate at about minus 120 dBm, 130. And a 50 kilowatt FM within about a half a mile or actually 3 miles is probably the equivalent of a C-band local transmitter being picked up by an LNA, LNB 3-meter dish. No, it's not the same thing. Sorry, it's not the same. I got it all wrong.
And listen, I wish we had more time because I'd like to talk about proposed remedies, because Mark just has this bad feeling that this just may go through. that we're all going to have to be very protective of our dishes, and there's going to be interference from time to time. And what do you do about remedying that? What does what do you have to prove, and what does the cell company have to pay you? And we don't have time to get into all that because it hasn't even been decided. But boy, broadcasters sure would like to make that expensive for cell companies if this all goes through and we end up with unreliable C-band service. Could be bad. Hey, we've got to. I should say it's not just broadcasters. Mark, you mentioned that the LDS Church, the Mormon Church, and other organizations use C-band distribution all over the place, right?
Oh yeah.
Mm-hmm. No, absolutely. We've adjusted C-band downlinks at FedEx in Louisville for NOAA. And different facilities. NOAA has stuff. The government has stuff. It's not just us.
Yeah. All right. Hey, we'll be right back. Our sponsor of this last part of the show is our friends at Lavo. We'll be right back with a couple of tips right after this.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
And thanks a lot to Lavo for sponsoring This Week in Radio Tech. Be sure when you go to lavo.com/TWiRT, because that'll take you right to the radio products that we talk about right here on This Week in Radio Tech. Man, there's so much more to cover on this great topic, and we ought to have Mark back after the comments are in, and we kind of see where this thing is going. I want to rely on Mark as my voice of good information to keep us up to date on the C-band issue. Do either of you have anything you want to add about that before we move on to our tips?
Just remember, if this goes through and things of this nature happen, that Internet of Things, the 5G, and all that wonderful stuff they give you for better services, and you could replace your downlink capabilities with this new 5G technology. Just remember who you're going to be paying the bills to.
Yeah. Yep.
Mark?
That free content delivery that you get on C-band is not going to be free anymore.
Right.
And it's unlimited.
Yeah, free unlimited data over C-band. Of course, we're paying for it in a very tiny way. We're by playing the ads and so forth and the ad content on the shows that we run. But that's all. That's right. It's the right economic way and the right technology to distribute media that we do. Okay. Anyway, hey, it's time for a couple of tips, and I'm going to start out because I'll forget if I don't. I have a quick quote for you. Because I have to preface my tip with this quote so that Chris won't get mad at me. Okay?
I won't get mad.
Well, you might. So the quote is this, and you may have heard this before. There is hardly anything in the world that some man cannot make a little worse and sell a little cheaper, and the people who consider price only will be this man's lawful prey. That was said by John Ruskin. All right. So, Chris, what I have to show you, I'm the lawful prey of this device right here. It is a digital thermometer, okay? And I'm going to show you that it does work. I'll take the temperature of my forehead here. You ready? Here we go. That was my glasses. 93.3. Let's go a little higher. 96.2 on my forehead. At Sam's Club. $19.95. $20. $20 freaking dollars. Isn't that amazing?
As long as you don't need a calibrated source, you're okay. That's fine.
If you know the temperature of something you're measuring, you can give it an offset. You can calibrate it, and it comes with this instruction book that gives you the corrective factor for emissivity. So if you're taking the temperature of a black not a black box, but what's it called? Black something device. Then you'll get the exact temperature. Actually, this is calibrated to 0.95 emissivity. So if you try to take the temperature of aluminum foil, you got a big multiplier there to apply. But I bet you do with the Fluke as well. The Fluke can't figure out automatically here.
No,
So,
it's the
sorry?
same thing.
Yeah,
Same thing.
So anyway, that's just kind of cool. It also has this function where you can give it a target temperature and a range. And then you can take temperatures all around that if you want to. And if they're lower, the screen will be green. If they're in the same range, the screen will be yellow, and higher, they'll be red. So you can, without having to read the numbers, you can quickly just look around somewhere and measure. And also it throws out a laser beam that shows you the area that you're taking the temperature of. See?
Nice.
That little circle, that circle right there. So anyway, $20 at Sam's. If you're not a high dollar guy like Chris Tobin is, you can go to Sam's and get this for $20. I'm happy with my purchase so far. I don't yet know if I'm lawful prey.
No, you're not lawful prey. No, the Fluke was for a project I was working on that the client required certain types of equipment to be used in order to ensure they would be happy.
Sure.
So
Yeah.
if I had a choice of the Fluke or Sam's Club, I'm sure I would have gone Sam's Club if I could make sure it's accurate. It doesn't have to be accurate to NIST standards, which is fine, but as long as it's close.
This, by the way, it's made in China, of course, like almost everything is, but it's a U.S. company called Vaughan. That's who apparently designed and marketed this thing. And so anyway, there you go. So far, I haven't found out that I'm sick. I did. I went around I went around the house measuring everything, right? Everything. And it's pretty, I was amazed at in my air conditioned house, how all the walls are within 1/10 the same temperature. I was also amazed at the Comcast modem I have here, which is a black body. That's the word I'm looking for. The Comcast modem I have has got this matte black finish all around it. It's like a black body. It was 114 degrees on the outside of that modem, and boy, you can feel it too. All right, enough of me, and we got to go shortly. Chris, do you have a tip for us?
Since we're talking C-band, satellite, SATCOM, and stuff, this is probably a good time for you to go and check on the positioning of your dish to make sure you have the maximum. Remember, the satellites, as they fly in their orbit, is sort of like a figure eight, so it's not really stationary. They're moving about, so you want to get those crosshairs of the figure eight, the crossover point. That's where you want to make sure you're maximizing, so that when it does go to the outer edges, you still have signal. So
and this is published online. In fact, I bet Mark, you could. What's the best way, Mark, to find out when it's in the center of the box?
The center of the box at SES and Intelsat, Telsat, Eutelsat, they all have a center of the box calculator on their websites.
Okay. Okay. Good.
All right. So as he talks about C-band and peaking it up, I'll admit to missing something, and it's something that it's actually the first troubleshooting thing I ever did back in the spring of 1984 on a C-band dish, and it catches me every once in a while. Sometimes I forget. Got a call from my cousin who engineers a station in Troy, Alabama, and he said, my EPNOs are down. I think the dish might have moved. Let's take a look at it. So drove up there, took a look at it, peaked it, moved it, polarized, checked all the cables. And it's just not getting where it's supposed to be. And I started wondering if it was, we were about ready to string it, make sure it hadn't warped. And I got up in there and looked up in there, and sure enough, 2 wasp nests inside the feed horn. So after spending 2 or 3 hours fiddling around, we realized there were wasps up in there. Anyway, got them out. So always take wasp spray with you, and especially in the spring and summer, check. But take a water bottle with you, because what I did was we cut off the bottom of the water bottle and stuck it up in the feed horn, and we had a new plastic cover.
Yeah.
And a 13 Ebno.
Easy to replace that every year too, because a lot of those feed horns used to come with a plastic cover, and they'd last a couple of years, and then they'd kind of get disintegrated. Plastic would disintegrate. So you can replace that every year. And by the way, I would add to that, Mark, if you're going to kill the wasp, the best time to do that is in the evening when they all come home and they're a bit docile, or first thing early in the morning before the sun rises. Kill them when they're all there and they're all kind of groggy. And then you'll get them all, because you don't want them coming back after you like, hey, where's my house? I'll build a new one. All right, good. Chris, do you get wasp nests in feed horns in New York City on a rooftop?
I cannot say that I recall having that happen, but you do tend to get birds. Small birds will do stuff. There are things you'll find up there.
Okay. Hey, I wish we had more time. Mark, this is a critical subject, and I want to touch base with you again after the comment period is over. In the meantime, we'll have links in the show notes. Please go there and register your dish. Get paid back for it if you can from SES's reimbursement program, and Intelsat may have that as well. I'll get both links in there. You can do your own research and call them up or see what they have to say. And then if you're in with your congressperson, well, the Energy and Commerce Committee is the one to talk to. I'm going to tell Marsha Blackburn, please end this madness. Don't let this happen, and because otherwise, the radio stations that you depend on to talk about you, Marsha, may not be able to talk about you, at least not easily. So, all right, thanks so much. Mark Johnson has been here from LiNKUP Communications. Mark, I'll put also, I know we didn't get a chance about talk about LiNKUP. I'll put your links as well in the show notes too, so folks want to get some of the services you guys do, that you can find them easily there. Okay.
All right. Thank you.
All right. Thank you, Mark. And Chris Tobin, thanks for joining us. Sorry you had to come in late, but glad you were able to anyway.
Yeah, no problem. No problem.
All right, man. You take care. We'll see you next week. Next week, we're talking about the AES convention in New York City, as well as a few other random radio topics. We'll see you next week on This Week in Radio Tech. Bye-bye.